These are your Chapter 14 in-class exercises. The first question says that the company made an investment which cost $48,000. The investment increased annual cash flow by $8,000 per year for a period of 6 years. The company desires a rate of return of 10% on all investment. The actual return from the investment was. And you can see from the answer choices, they're basically just asking what the return is relative to the desired rate of return. So we just want to know if it's less than 10%, equal to, or more than. There's a couple different ways you can do this. You can calculate the net present value, or you could calculate internal rate of return, either one. If we wanted to calculate the net present value, remember to calculate the net present value, what we're looking for is the future cash flow. So we're receiving $8,000 every year for a period of 6 years. We want to put that in present value form. So we want to look at your present value table. This is going to be an annuity, so you want to look at the annuity table, 6 years. A desired rate of return of 10% is going to give you a present value factor of 4.355. So when you multiply that out, that equals $34,840. The cost is $48,000. So that's going to actually give you a negative net present value of $13,160. So that means that the actual rate of return is less than the desired, okay? Or that really basically here there is no return on your investment. So your answer choice, the correct answer here is A, less than the desired rate of return. Question number 2 says, what is the value today of a payment of cash of $30,000 to be received in 3 years if the rate is 10%? So here, what you're looking for is the present value of a single sum. Okay, so we're looking for the present value of receiving $30,000 of cash 3 years from now. So to put this in present value table, you want to use the single sum table. So if you look at the value of a single dollar, 10%, in year 3, your present value factor is 0.751. Multiply that by the $30,000, and so it's $22,530. The second part of the question says, what's the value today of $10,000 a year for 3 years? So what's changing here is that you are receiving $30,000 every year for 3 years. So that, you're receiving $10,000 every year for 3 years. So that means that this is an annuity. So you want to use the annuity table. Your timeline is 3. Desired rate of return is 10%. So your present value factor is 2.487. So when you multiply that out, it's $24,870. Question number 3 says that Bob's construction company purchased a new front-end loader for $35,609. The machine has a 5-year useful life, no salvage value. The new machine will generate $10,000 in additional cash flow each year. Bob has a hurdle rate of 10%. Based on this information, what is the net present value of the machine? So in order to calculate net present value, remember what you're doing is you're taking the present value of the future cash flow and subtracting from it the initial investment. So the cash flow that you are receiving every year is $10,000 every year for 5 years. That makes it an annuity. So your present value factor is 3.791. So the present value of all the future cash is $37,910. Subtract from it the initial investment of $35,609. So you have a net present value of $2,301. The fourth question says that the company invested in a project with a payback period of 4 years. The project brings $30,000 a year for a period of 8 years. What's the initial investment? Basically, if you remember for payback period, your formula for payback period is to take the initial investment and divide it by your annual cash flow. So here, we're working backwards. We know that the payback period is 4. What we don't know is what the initial investment is, and we know that the annual cash flow is $30,000 a year. So you're just cross multiplying to solve for the X. So your X is $120,000. So that's going to be the initial investment. The second question, part of the question says, what is the internal rate of return? Well, to calculate internal rate of return, remember you're going to do basically 2 different things. The first thing to come up with internal rate of return is to find, so step number 1 is to find the present value factor. To find the present value factor, it's the initial investment divided by annual cash flow, which if you look up what we just typed, that's obviously the payback period. So we already know that the present value factor is 4, but just to work it out, you have an initial investment of $120, your annual cash flow is 30, so your present value factor is 4. So to find the internal rate of return, you then go look the payback period, or I'm sorry, then you go look the present value factor up on your table. So if we have a payback period of 4 years, and it's every year, so that means it's an annuity. So if you come down here and look at your annuity table, it's for 4 years. That's for 4 years. Your factor is also 4. So basically you're looking for 4 in this row right here. You'll notice as you look across, the numbers tend to get smaller. So the 4 is somewhere on this side, so it's less than 6%. So even though we don't know exactly know I'm sorry, and I apologize for the timeline on this one. Your payback period is 4 years. However, your years is 8. I'm sorry. So I'm looking on the incorrect timeline. Okay. So you are looking on timeline of 8, and your present value factor is 4. So we want to read this from the table. You are looking for 4. It's going to be somewhere between 18 and 20%. Okay, so it's approximately, it's approximately 19%. So somewhere between 18 and 20%. That's going to be your internal rate of return. The next question says that we project that we can get $60,000 cash every year for 4 years on a real estate investment project. If we want to earn a rate of return of 14%, what is the maximum amount we should pay for the investment? Okay, so if you have a question that's asking you for the maximum amount that you should pay, what you're looking for is the present value of the future cash. So if we're looking for the present value of the future cash, you want to take your future cash flows, which it tells you we're going to get $60,000 every year for 4 years. We want to multiply that by the present value factor from the table. So it's an annuity because it's per year. Your timeline is 4 years. Your percentage is 14%. So your factor is 2.914%. I'm sorry, it's just 2.914. So it's 174,870. So that's the maximum amount that you should pay. The next question says that we're considering 2 different projects, Project A and Project B. It gives you the cash. The initial investment for each project is $150,000, and then it gives you the cash flow. And the question says, what's the payback period for each project? So if we look at this for Project A, for payback period for Project A, the payback period is really easy if you're getting an even cash flow, which we are here. If you're receiving an even cash flow, you can just use your basic equation where you take the initial investment divided by your annual cash flow. So I can do 150,000 divided by $50,000. So that gives you a payback period of 3 years. So not too bad. And for project B, this is where we have to look at it year by year. So basically, after year 1, we have 40,000. Year 2 gives us another 40. So after 2 years, we have $80,000. After year 3, we have another 40. So now we have 120,000, and we're trying to get obviously up to 150. So after 3 years, we have $120,000. Then we get to year 4. So going into year 4, we've already collected 120,000. We need 30,000 more to get to 150. Year 4 brings in 60,000. So basically, we don't need all of year 4. We only need a piece of year 4. So to figure out how much you need out of year 4, you basically take the cash that you need. So you need 30,000 more out of what you are going to get in that year. And so that's going to tell you what portion of that year you need. So basically, I need all of year 1 plus all of year 2, all of year 3 plus half of year 4. So your payback period is 3.5 years. The second part of the question is asking for accounting rate of return. To come up with the accounting rate of return, what you're taking is the initial investment, and you are dividing it by your annual income for each year. So your average annual income. Now, for average annual income, that is going to be your cash minus any additional expenses, like any non-cash expenses. And one expense that is typically a non-cash expense is going to be depreciation. So basically what I'm going to do up here is I'm going to end up finding your average cash flow for all 5 years. So for project A, your annual average cash is $50,000. For project B, I'm just going to average, okay? So I've got 40,000 from year 1, 40,000 from year 2, 40,000 from year 3, 60,000 from year 4, 80,000 from year 5. So over 5 years, we're going to collect $260,000 of cash, divide that by 5, the number of years, and that's going to give you average annual cash, okay? So on average, we're collecting $52,000 a year. Now, we need to subtract from that any non-cash expense. The non-cash expense that you're going to look at is depreciation. In here, to collect depreciation, you're only going to use straight line. Okay, so for straight line depreciation, remember you're going to take the cost of the asset, divide it by the useful life. We are not worried about salvage. So we assume straight line, 5 years, so that's going to give you $30,000 of depreciation a year. So your average net income for project A is $20,000, and your average income is $22,000 for project B, and that's what you're going to use to calculate the accounting rate of return. So for project A, $150,000 divided by $20,000 gives you reverse the formula. Annual income divided by investment. So you've got $20,000 of annual income divided by $150,000 of investment. So for project A, it's 13.33%, and then for B, $22,000 divided by $150,000, and that's going to give you 14.7%.